Alright, so let's start analyzing this square root function as much as possible. And the first thing I'm going to do is find the vertex H and K, so I can write this in standard form. Remember that standard form looks like this. I'll write it in red. Standard form looks like this. Y equals a square root of b x minus h plus k. Alright, so this is what our standard form looks like. So let's try to get standard form in this one here. So we have y equals 4 square root. Now what I do is I factor out the coefficient that is in front of my x. That's a 4, so I factor out the 4. X minus 2 plus 1. Okay, so now I can see that my h and k, which means my starting point, is 2, 1. So starting point s is 2, 1. Alright. Now let's try to describe the domain of this function. So the domain, which I'll call D. Well, to find the domain, what I do is I find the restrictions of my graph. What that means is whatever's under the square root has to be greater than or equal to 0. It can't be negative. So 4 times x minus 2 has to be greater than or equal to 0. Dividing both sides by 4, I get x minus 2 has to be greater than or equal to 0. Just take note here that if my b were negative, and I divided both sides by negative, then this sign, the inequality, would have to switch directions. But here, my 4 is positive, so dividing both sides by 4 does not change the inequality. Now bringing the 2 to the other side, that means that x has to be greater than or equal to positive 2. So my domain is x belongs to the set of numbers 2 all the way to positive infinity. The range we can tell from h and k, so I know that my graph is going upwards because my a is positive, and my starting point in the y coordinate is 1. So my range is y is an element of, so starting at 1 included all the way to positive infinity. So this is my range. Alright, let's keep going. Let's try to graph this very quickly. So let's make a sketch of a graph, something like this. Okay, so that I know my domain, so let's put the starting point and then let's take a look at what the domain tells us. The starting point I'll put in green. It's at 2, 1. So let's say 2, 1. It's over here. And the domain says that I'm going from 2 all the way to positive infinity, so that's all these points over here. My range says from 1 all the way to positive infinity, so I'm going to be doing something sort of like this. Now, for a more precise sketch, you can always choose a point for x and y, plug it in, and then find it somewhere else on your graph, and then connect the dots. But for me, this is a simple sketch, so just to get an idea of what's going on, this is what it looks like. If I tried to find the zeros, I would have a problem because according to my sketch, the line never crosses the x-axis, therefore I don't have any zeros. But let's see what happens if I try to solve for zeros. So zeros, what do? I make y equal to 0. So 0 equals 4 square root 4x minus 2 plus 1. Now let's try to solve for this. So bringing 1 to the other side and dividing by 4, I get negative 1 over 4 equals the square root of 4x minus 2. Now this gives us a problem because the square root over here can't be negative. And so when we say the square root of this is negative, we come across a problem. And that's to be expected because, well, we don't have any zeros. right? The graph never crosses the x-axis. So from this point over here, we can say, okay, done. I know that there's no zeros. All right. If I tried to find the y-intercept, I'd have also a problem because, well, there is none. From the graph, we can tell there's none. But let's try to do it anyway. To find the y-intercept, I have to make x 0. So y equals 4 square root of 4 times 0 minus 2 plus 1. And that gives us 4 times the square root of 4 times minus 2 is minus 8 plus 1. And from here we can tell that there's a problem because we can't actually take the square root of a negative number. So this is impossible. And from here we conclude that there is no y-intercept. So y-intercept equals empty set. There is none. Okay, moving on. Maximum and minimum. Well, because this function's increasing, there's no maximum, but it does have a minimum, and the minimum is the y value of your starting point. So it's the k value. So minimum, min, equals, or not equals, but min arrow, y equals 1. So my minimum is y equals 1. And this is always true. It's always true that the minimum of a square root function, the minimum or maximum of a square root function, is the k, so the y value of your starting point. After that, we will try to find the inverse of this function. So let's do the inverse now. So the inverse we get by interchanging x and y. So let me just recopy the formula so that I know what I'm dealing with. So 4 root 4 x minus 2 plus 1. So let's interchange the x and the y. So the x takes the place of the y 4 times, and the y takes the place of the x. Minus 2 plus 1. And now we just solve for y. So we bring the 1 to the other side. This gives us x minus 1 equals 4 root 4 y minus 2. Dividing both sides by 4, I get 1 over 4 times x minus 1 equals the square root of 4 y minus 2. Now I square both sides to get rid of the square root. What that gives me is 1 over 16 x minus 1 squared equals 4 y minus 2. I divide both sides by 4 to get rid of that 4. So this gives me 1 over 64 x minus 1 squared equals y minus 2. And finally, I bring the 2 to the other side and I get 1 over 64 x minus 1 squared plus 2 equals y, and that's my inverse. So take a good look at this. My inverse looks a lot like a standard form of a parabola, and that's normal because we can tell intuitively that the square root function and the parabola square function are inverses of each other, opposites. So we're not done at this point because the square root function had a restricted domain. The domain was restricted. It did not include all possible real values. So this means that my new function here, my inverse function, also will have some kind of restriction. But how do we find this restriction? Well, the thing is, all the x values and all the y values were interchanged, so the new restriction is, so the domain now is the range of my old function, and my range is now my domain. So the domain now is from 1 to positive infinity. That was the range of the old function.